Type D thermomagnetic circuit breaker is a specific type of circuit breaker often used in industrial and commercial settings. Its primary advantage lies in its ability to handle higher inrush currents compared to standard Type B circuit breakers. The term slow blow characteristic describes the behavior of a Type D circuit breaker. This means that it has a higher magnetic trip setting than a standard circuit breaker. This higher setting allows the circuit breaker to tolerate short duration overcurrents. These overcurrents are commonly produced when starting motors or when other heavy-duty loads are initially energized. Without this tolerance, the circuit breaker might trip unnecessarily, disrupting operations. Key features of a Type D circuit breaker include firstly, a high magnetic trip setting. Type D circuit breakers typically have a magnetic trip setting that is 10 to 12 times the rated current. This is significantly higher than Type B circuit breakers, which usually trip at 5 to 8 times the rated current. Secondly, a time delay feature. In addition to the high trip setting, Type D circuit breakers incorporate a time delay in their magnetic tripping mechanism. This delay allows them to withstand overcurrents that last for only a short period of time. Thirdly, current limiting capabilities. Like Type B circuit breakers, Type D circuit breakers provide current limiting protection. This means that they can effectively interrupt short circuits by rapidly reducing the fault current. This feature is essential for preventing damage to equipment and ensuring safety. Type D circuit breakers are commonly used in several applications. 1. Motor starters. Motors, especially large ones, draw a significant amount of current when they start. Type D circuit breakers are ideal for these applications because they can handle the inrush current without tripping. 2. Transformers. Transformers can also experience inrush currents when they are initially energized. Type D circuit breakers can protect transformers from these transient overcurrents. 3. Heating, ventilation and air conditioning or HVAC systems. HVAC systems often involve motors and other components that can cause inrush currents. Type D circuit breakers are suitable for protecting these systems. 4. Industrial machinery. Industrial machinery often involves heavy loads and motors that can generate overcurrents. Type D circuit breakers are a reliable choice for protecting this equipment. 5. Lighting systems. Certain lighting systems, especially those with ballast, can also produce inrush currents. Type D circuit breakers can provide the necessary protection without nuisance tripping. It is important to note that the specific trip characteristics of a Type D circuit breaker can vary between manufacturers. Therefore, it is always recommended to consult the product datasheet for detailed information. This will ensure that the circuit breaker is properly selected and applied for the intended application. When selecting a circuit breaker, several factors must be considered to ensure proper protection and operation. Firstly, determine the load requirements. Calculate the continuous current and the expected inrush current of the load that the circuit breaker will protect. Secondly, choose the appropriate trip curve. Select a circuit breaker with a trip curve that matches the load characteristics. Type D circuit breakers are suitable for applications with high inrush currents. Thirdly, verify the voltage and current ratings. Ensure that the circuit breaker's voltage and current ratings are compatible with the electrical system. Fourthly, consider the ambient temperature. The ambient temperature can affect the circuit breaker's performance. Choose a circuit breaker that is rated for the expected temperature range. Fifthly, check the interrupting capacity. The circuit breaker's interrupting capacity must be sufficient to handle the maximum fault current at the installation location. Proper installation and maintenance are crucial for ensuring the reliable operation of circuit breakers. Firstly, install the circuit breaker correctly. Follow the manufacturer's instructions for installing the circuit breaker. Ensure that all connections are tight and secure. Secondly, protect the circuit breaker from environmental factors. Protect the circuit breaker from moisture, dust, and other environmental factors that could affect its performance. Thirdly, test the circuit breaker regularly. Periodically test the circuit breaker to ensure that it is functioning properly. This can be done using a circuit breaker tester. Fourthly, replace faulty circuit breakers promptly. If a circuit breaker fails to trip or trips unnecessarily, replace it immediately. A faulty circuit breaker can compromise the safety of the electrical system. Additionally, when using Type D circuit breakers, consider these specific points. 1. Coordination with other protective devices. Ensure that the Type D circuit breaker is properly coordinated with other protective devices in the electrical system, such as fuses and other circuit breakers. This will prevent cascading failures and ensure that the fault is cleared by the nearest protective device. 2. Application-specific considerations. Consider any application-specific requirements when selecting a Type D circuit breaker. For example, some applications may require a circuit breaker with specific certifications or approvals. 3. Consulting with a qualified electrician. It is always recommended to consult with a qualified electrician when selecting and installing circuit breakers. A qualified electrician can assess the specific requirements of the application and recommend the appropriate circuit breaker. Type D circuit breakers are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the rated current of the circuit breaker. Short circuits occur when there is a low resistance path between two conductors, causing a large amount of current to flow. Type D circuit breakers use two different mechanisms to protect against these conditions. Firstly, a thermal element. The thermal element responds to overloads. It consists of a bimetallic strip that bends when heated by the current flowing through it. When the strip bends sufficiently, it trips the circuit breaker. Secondly, a magnetic element. The magnetic element responds to short circuits. It consists of a coil that creates a magnetic field when current flows through it. When the magnetic field is strong enough, it trips the circuit breaker. The combination of these two elements provides comprehensive protection against both overloads and short circuits. The tripped curve of a circuit breaker describes the relationship between the current flowing through the circuit breaker and the time it takes for the circuit breaker to trip. Type D circuit breakers have a specific trip curve that is designed to accommodate high inrush currents. The trip curve of a Type D circuit breaker typically has two distinct regions. Firstly, a thermal region. In the thermal region, the trip time is inversely proportional to the current. This means that the higher the current, the faster the circuit breaker will trip. Secondly, a magnetic region. In the magnetic region, the trip time is very short, typically less than a cycle. This allows the circuit breaker to quickly interrupt short circuits. The trip curve of a Type D circuit breaker is designed to allow for short duration overcurrents without tripping. This is achieved by delaying the magnetic trip response. The specific trip characteristics of a Type D circuit breaker can be found in the manufacturer's datasheet. The datasheet will provide detailed information about the trip curve, the magnetic trip setting, and the time delay. When selecting a circuit breaker, it is important to consider the available fault current at the installation location. The available fault current is the maximum amount of current that can flow in a short circuit. The circuit breaker must have an interrupting capacity that is equal to or greater than the available fault current. If the circuit breaker's interrupting capacity is less than the available fault current, the circuit breaker may fail to interrupt the short circuit, which can result in damage to equipment and injury to personnel. The available fault current can be calculated using a fault current calculator or by consulting with a qualified electrical engineer. The calculation takes into account the impedance of the electrical system, including the transformers, conductors, and other components. In addition to the interrupting capacity, it is also important to consider the circuit breaker's voltage rating. The circuit breaker's voltage rating must be equal to or greater than the voltage of the electrical system. If the circuit breaker's voltage rating is less than the voltage of the electrical system, the circuit breaker may fail to operate properly. Circuit breakers are typically available in a variety of voltage ratings, such as 120 volts, 240 volts, 480 volts, and 600 volts. The appropriate voltage rating will depend on the specific application. The National Electrical Code or NEC provides guidelines for the selection and installation of circuit breakers. The NEC specifies the minimum requirements for the interrupting capacity and voltage rating of circuit breakers. The NEC also provides guidelines for the overcurrent protection of electrical circuits. The NEC is updated every 3 years, so it is important to consult the latest edition to ensure compliance. Some specific NEC articles that are relevant to circuit breakers include Article 240, which covers overcurrent protection, and Article 430, which covers motor circuits. These articles provide detailed requirements for the selection and installation of circuit breakers in various applications. In addition to the NEC, there are other standards and certifications that may be relevant to circuit breakers. For example, Underwriters Laboratories, or UL, is a widely recognized testing and certification organization. UL tests and certifies circuit breakers to ensure that they meet certain safety and performance standards. Circuit breakers that are UL listed have been tested and certified to meet the requirements of UL 489, which is the standard for molded case circuit breakers and circuit breaker enclosures. Another relevant standard is the International Electrotechnical Commission, or IEC Standard 60947, which covers low voltage switchgear and control gear. This standard provides requirements for the design, construction, and testing of circuit breakers. Circuit breakers that comply with IEC 60947 are suitable for use in international applications. When selecting a circuit breaker, it is important to consider the specific requirements of the application and to choose a circuit breaker that meets all applicable standards and certifications. This will help to ensure that the circuit breaker provides reliable and safe protection for the electrical system. Regular maintenance and testing of circuit breakers are essential for ensuring their continued reliable operation. Circuit breakers should be visually inspected periodically for any signs of damage or wear. The connections should be checked to ensure that they are tight and secure. The circuit breaker should also be tested periodically to ensure that it is tripping properly. There are several different methods for testing circuit breakers. One common method is to use a circuit breaker tester, which applies a controlled current to the circuit breaker and measures the trip time. Another method is to use a high current test set, which can simulate a short circuit and verify that the circuit breaker interrupts the fault current. The frequency of testing will depend on the application and the environment. Circuit breakers in critical applications such as hospitals and data centers should be tested more frequently than circuit breakers in less critical applications. In addition to regular maintenance and testing, it is also important to keep accurate records of all circuit breaker maintenance and testing activities. These records can be used to track the performance of the circuit breakers and to identify any potential problems. When replacing a circuit breaker, it is important to choose a replacement circuit breaker that has the same or better ratings as the original circuit breaker. The replacement circuit breaker should have the same voltage rating, current rating, and interrupting capacity as the original circuit breaker. It is also important to ensure that the replacement circuit breaker is compatible with the existing electrical system. When installing a new circuit breaker, it is important to follow the manufacturer's instructions carefully. The circuit breaker should be installed in a suitable enclosure that provides adequate protection from the environment. The connections should be tightened to the specified torque. The circuit breaker should be tested after installation to ensure that it is operating properly. Circuit breakers are an essential component of any electrical system. By understanding the different types of circuit breakers, their applications, and their maintenance requirements, you can ensure that your electrical system is properly protected. Remember to always consult with a qualified electrician when selecting and installing circuit breakers.